So this is the Chem 1 lesson over percent composition. And percents are things that students have been exposed to since they were very little. For example, if you took a 70 question test and you got a 61 questions correct, what's your grade on the test? You could probably calculate this pretty easy. You'd say, okay, well, I got 61 questions correct out of 70 possible. So I would get 61 divided by 70, it ends up being close to about 0.87. Now that's not a grade you're used to looking at. To turn it into out of 100, you multiply it by 100 and you're going to get an 87. So really, what you did is you used the part you got correct over the whole test times 100. That's your generic formula for a percent. That's what we're going to use. When we're talking about a compound, the part would be whatever element you were that you were referring to, divided by the whole being the mass of the entire compound, which would be your molar mass. Remember, if you're finding the percent composition of all of the elements, you can add up all those percents and it should equal pretty close to 100 depending on rounding. And to keep things simple in here, we're going to go ahead and report percents to 2 decimal places. Just because we're using our periodic tables, I could also go to 2 decimal places. So our first example, if there are 95 grams of barium and 26.3 grams of fluorine in a compound, what is the percent composition of the compound? So we want to know what's percent that's barium and what's the percent that's fluorine. So I've got both parts. I've got the mass of barium and I've got the mass of fluorine, but I don't have the whole. I don't know the mass of the entire compound. To find the mass of the whole, I just have to take both parts. So 95.0 grams of barium plus 26.3 grams of fluorine is going to give me my whole of 121.3 grams. So that's my whole. Okay, from then out, let's do barium. So for barium, I know that 95 grams of it is barium out of 121.3 grams of the whole times 100 to turn it into a percent. You're going to get 78.32% barium. Same thing, mentioned before, 2 decimal places. Now be sure in your percent to list out what element it is. If you just told me it was 78.32%, I won't know if you're talking about barium or fluorine. So you want to be sure to list what element you're talking about in your answer. So now at this point, since we know that it's only made up of 2 things and we know the part that's barium, we should be able to take the 78.32%, subtract that from 100 to get our fluorine. And you can do that. I suggest reworking for fluorine as a way to double check your work, because we need to make sure whatever answer we get for fluorine will add up with barium to make 100. So I am an advocate of working it out separate. So fluorine, we know that it weighs 26.3 grams divided by the whole, same whole, 121.3 grams times 100. And you're going to get 21.68% is fluorine. Same thing, if we look at those 2%, so if I add it up, that's going to be exactly 100%. Now the next example, if iron makes up 69.94% of the mass of iron 3 oxide, calculate the mass of iron present in 250 grams of iron 3 oxide. So this one's a little bit different. In the given problem, we've got percent, and this other number we're given, 250 grams, that would be our whole. So this one's going to work out a little bit differently. So we've got so remember it's part over a whole times 100 equals our percent. So if we're going to map this guy out, we have our whole, we have our percent, we're asked to find the part. So when we go through and plug these guys in, we don't know our part, I'm just going to leave it a P. But I do know the whole. I know the whole is 250 grams times 100 should equal 69.94%. Now, it's just an algebra problem. I find that what's easiest to do with this algebra problem to solve for part is to divide both sides by 100. And when you do that, you end up with a proportion. So then you can just cross multiply. So you get P times 100 equals 250 times 69.94. So divide both sides by 100, and you're going to get that P equals 174.85 grams. Since this is not a percent, we should be able to round this to 3 sig figs. So it's actually going to become 175 grams of iron. This isn't a percent, so we don't need to worry about 2 decimal places. We need to round to those sig figs. So in this time, we were asked to find part. So our first one we found percent. This time we found part. Next one's going to be a bit different. In the third example, we're given that we have 40.2 grams of calcium in calcium hydroxide. We want to know the whole. We want to find the total mass of the sample, and we're given the entire percent composition. So we've given grams of calcium, so we've got our part, and then we've got the entire percent composition, but we don't need all of it. The only element we're interested in is calcium. So this is actually the only percent we need. The rest is extra information. So let's see. Out of our equation, part over a whole times 100 equals percent. Let's see what we've got. We've got our part. We've got 40.2 grams. We've got our percent. The whole is what we're trying to find here. So we're going to plug in our numbers. I've got 40.2 grams of calcium up top over our whole. We don't know it. You can make it X. I'm going to go ahead and leave it as a W. Times 100 is going to equal 54.10%. Same thing, divide both sides by 100. Then we've got a proportion. We can cross multiply and divide. And when you do that, and again, we don't have percent, so we can round to our sig figs. We're going to want to find 3 sig figs. You're going to end up that the whole equals 74.3 grams. And the whole this time is calcium hydroxide. So calcium hydroxide. And our last one's a little bit different. We don't have any numbers at all. It just says calculate the percent composition of potassium sulfate. If we don't have any numbers, we could really get to pick. And the easiest thing, the only feasible thing to use are the numbers off the periodic table. So we're going to assume we have 1 mole. So we just need to find the molar mass. So we need the formula for potassium sulfate. So potassium and sulfate, let's see. Potassium's +1, but sulfate's -2, so it's going to be K2SO4. So the first thing we need to do is find the molar mass for this. So I've got K, and there's 2 of them. So 2 times, you've got to look up potassium on your periodic table. You get that it's 39.10 grams per mole. Double that guy, you're going to get 78.20 grams per mole. And then we've got sulfur. There's only 1 of them. So 1 times, look it up on your periodic tables. You get 32.06 grams per mole. And then the last one is oxygen. There's 4 of them. Each of them from the periodic table is 16. So 4 times 16 gives us 64 grams per mole. So if we add all of these guys together, we're going to get the molar mass, and it ends up being 174.26 grams per mole. This right here is our whole. And guess what? Each of these guys up here are our parts. So we've already got it halfway set up. So I got to take my part divided by my whole, 174.26 times 100, equal my percent, that's potassium. Got to take the sulfur, I'm going to divide it by the same whole, 174.26 times 100. It's going to be my percent, that's sulfur. And last, oxygen, same thing, divided by 174.26, multiply it by 100. We're going to get our percent, that's oxygen. So everybody take a second, pause the video, find these 3 percents. So once you get those percents, you should find that potassium is 44.88%. You should find that sulfur is 18.40%. And last, oxygen is 36.73%. You add those three numbers together and you'll get pretty close to 100%, so you know you've done it correctly. So if you're not given any numbers at all, just remember you can assume 1 mole, use those molar masses off your periodic table. Your molar mass will be your whole, and then each individual part in the whole can get you all of the percents.